Hello Pre-Calc students, we're starting our conics unit and the first lesson is on circles and ellipses. The definition of a circle is the set of all points that are equidistant from a fixed point called the center. This is the standard form of a circle, and h, k would be the center of your circle, r would be the radius of your circle. If you're looking at an equation and you want to determine whether or not it could be rewritten as the equation of a circle, you're looking for an equation where both the x and the y are squared and their coefficients are the same. For example, here, they're 3 and 3. So let's try to graph some circles. In the first one, we just have x squared and y squared. There's no h and k. So if you were to add in the h and k, it would be x minus 0, y minus 0. So that puts your center at 0, 0. 25 is equal to r squared. So you could rewrite it as 5 squared, and that tells you that the radius is 5. The radius is just going to be the square root of this number here. So let's graph a center of 0, 0. And from that center, you go 5 in every direction. The easiest directions are right and left, up and down, and then you just need to sketch the circle from there. It's difficult to draw a circle, but do your best. Don't draw a diamond. It's especially difficult on a smartboard. Okay. In the next example, we have a circle, and we're trying to determine the equation. So the first thing we want to do is find the center. So it looks like it's about here, and then just double check. We're going 3 in every direction, so that's right. So the center is at -2, 1. And the radius is 3. So using my equation from above here, I have x minus h squared. This is my h, this is my k. So x minus -2 makes +2, plus y minus 1 squared, and that's going to equal 3 squared, and 3 squared is 9. Alright, so this would be a good point to pause the video and try problem 3 on your own before watching the solution. Okay, in problem 3 it says x plus 1 squared, but the form is supposed to be x minus, so that would be like x minus -1 squared. So that puts my center at -1, 3, and the radius is the square root of this number, so the radius is 4. So I go to -1, 3, and then I go 4 in each direction. And then sketch in your circle. Okay. Now we have a new shape called ellipse. An ellipse is a set of points such that the sum of the distances from a point on the ellipse to two fixed points called the foci is constant. So you can see here, here's a point A, and if I add AF1 to AF2, that distance will be the same, let's see if I can get a new color, as the sum of the distance from B to F1 plus B to F2. So this blue plus this blue is equal to this green plus this green. And that's true of any point on the ellipse. We have something called the major axis, which is the segment going through the foci and ending at the vertices. So your major axis is just the longer axis. And then the minor axis is perpendicular through the major axis going through the center. So here's your minor axis. This one is the major. It's just the longer one. Alright, and you have two equations for the ellipse, but really they're the same equation if you look carefully. The only thing that switched is a and b, And what this is telling you is that the bigger value is going to go first here and second here. If you have a longer major axis, then that's going to go underneath the x minus h squared. And if you have a longer, well, actually you always have a longer major axis, but if you are longer in the vertical direction, then the bigger number goes underneath the y. I don't think I made that clear yet, but let's look at the examples and see if I can make it more clear. Recognizing the equation of an ellipse, if you're looking at an equation and trying to determine if it could be rewritten as an ellipse, you're looking for one where x and y are both squared. The coefficients are both positive, but they're different. So in this example, one coefficient is 3 and one is 2. All right, let's turn the page. All right, this equation does not look like what we're going for. We were going for x minus h squared. We're looking for y minus k squared, and then there's going to be an equals 1 here, and then the a was either here or it was here. We'll figure that out in a second. So the first thing we want to do is make an equals 1. So we're going to divide 64 by 64, and then we'll divide both sides by 64. And now I have 16 over 64, which simplifies to 1/4. So I get x squared over 4 plus, I have y squared, 4y squared over 64. 4 over 64 is 1 over 16. So I have y squared over 16. And that's going to equal 1. All right, so because the 16 is larger than the 4, that's your A. Okay. Okay, so we're going to graph the center at 0, 0, because what we have here is don't have x minus anything or y minus anything. So the center's at 0, 0. And we can think of 16 as the square of 4, 4 squared, and 4 as the square of 2. So going in the y direction, we're going to go 4 up, and we're going to go 4 down from the center. And going in the x direction, we're going to go 2 left and 2 right. And then this is going to determine the shape of our ellipse. Alright, so then if you need to graph the two foci or foci, there's, I've heard it pronounced both ways, then there's an equation, c squared equals a squared minus b squared, kind of close to the Pythagorean, but don't be confused by that. And the c squared is what we're trying to find. The a squared is the a squared from this equation, so it's 16. And the b squared is 4. So c squared is equal to 12, and c is square root of 12, which you would simplify to be 2 root 3. So you could use a calculator to estimate the square root of 12, or you could just figure that it's bigger than the square root of 9 and smaller than the square root of 16, so it's somewhere between 3 and 4. So if you're just graphing it as an estimate, you can graph it somewhere between 3 and 4. And those are your two foci. Alright, next one. Okay, looks like my center is going to be at -1, +3. And my a squared is 25, so a is 5, and my b squared is 4, so b is 2. So find your center at -1, 3. Because this is underneath the x, we're going to go 5 in the x direction. 1, 2, 3, 4, 5. And this way as well. And then we're going to go 2 in the y direction here and here. And so sketch your ellipse. Oh, this is not too neat. Okay, and then if you want to find your two foci, you would do c squared equals a squared minus b squared. And that would be 25 minus 4. So c squared equals 21, and c is the square root of 21. So square root of 21 is going to land between 4 and 5. So you want to graph your two foci between 4 and 5. Alright, this last one would be a good one to try on your own. Is this the last one? Nope. Sorry, but this next one would be a good one to try on your own. So go ahead and find your center, and then find your A and B and see if you can draw a quick sketch. Okay, let's see if you did it right. So your center will be 2, 0. 9 is 3 squared, and 36 is 6 squared. So you go to 2, 0. And because 3 is underneath x, you're going to go 3 in the x direction. And you're going to go 6 in the y direction. And draw a sketch. Okay, so for the foci, you're going to do c squared equals a squared. Remember, a is just the larger of the two. So 6 squared minus b squared minus 3 squared. So 36 minus 9 is 27. And c is going to be the square root of 27, which does simplify to 3 root 3. Square root of 27 is a little bit bigger than the square root of 25, so just a little bit more than 5 away. And remember that these are always on the major axis, so the foci will always be on the longer of the two axes. Okay, so to write the equations, you're just working backwards. Let's find the center to start. So looks like it's going to be maybe here. I'll just check and see if I'm right. So I'm going 5 to the right, 5 to the left, 3 up, and 3 down. So that's my center. So I'm going to have x minus 1 squared and y minus 1 squared. Alright, in the x direction, I'm going 5 from the center, so 5 squared is 25. In the y direction, I'm going 3 from the center, 3 squared is 9, and then you need an equals 1. Alright, this would be a good place to pause and try this last one on your own. And then let's see if you did it right. So my center seems to be here. Let's see, I went 7, so that's 5 up and 5 down, yes. Okay, so my center is at -3, +2. So x minus -3 is x plus 3. Y minus 2. Okay, in the x direction, I'm going 3 from the center, so 3 squared is 9. In the y direction, I'm going 5 from the center, 5 squared is 25, and then that equals 1. That's the equation of your ellipse. Alright, so now you have a set of classwork and homework problems. Try the classwork problems, and you can check those problems with your key on Blackboard.